DC circuits, electrical circuit types. So now we will basically discuss different types of DC circuits, like different types of direct current circuits. So we have basically linear and non-linear circuits. So what are linear circuits? Electrical circuits containing only linear resistances, resistive elements for which the volt ampere characteristics is a straight line. So this is a very important property, a defining property of a linear circuit. So when we will call a circuit to be a linear circuit, when the VI graph will be a straight line. So the idea is that, see, for any circuit, for any electrical circuit, we can draw a VI graph. So how we will draw this VI graph? That is very easy. Like you can design your own circuit. You design your own circuit, like you introduce n number of different components in it. Now what you do, you take some voltage, okay, and measure the current corresponding to that voltage. So for example, if you have a voltage of 0 and current is also 0, so this 1 point you will get. Now let us suppose you have a voltage of like 2 volts and current you are having around 2 ampere, then this point you will get. And similarly, now you increase the voltage to 4 volt in your circuit, like you have your own circuit, a fancy circuit, wherein like you did all the jugaad, like introduce all the components in a very messy way, in whatever way you want. What you are doing, you are just passing the voltage, like potential difference, and you are measuring the current. And when the potential difference is 4 volt and current you found to be around 4 ampere, this is the point you got. And you repeated it for some other values also. Then you tested for 6 volt and you found like around 6 ampere, something of that sort. So now definitely when we will plot this, it will be a straight line. If it is not perfectly straight, if like it is tending to a straight line, then also it's fine. Then you can confidently say that, okay, the circuit which I designed is a linear circuit. Because linear circuit, what is the property of linear circuit? VI graph will always be a straight line. It means that it will follow the Ohm's law. Because what is Ohm's law? Very important discussion I am making. Ohm's law says that V is directly proportional to I, or V is equal to IR. So this is the Ohm's law. Like V is directly proportional to I. So linear circuit always they follow this pattern. V is directly proportional to I. It means that in a linear circuit, if you will increase the potential difference, if you will increase the voltage, if you will increase the energy, definitely current will increase for sure. For example, here I am having one example of a linear circuit wherein I am having a resistance which is connected in series with an inductor. So now this resistance and this inductor is connected in series. If I take different voltages and I measure the current, the value of current, so it will always follow a straight line, because here this capital V will be equal to ER plus EL, because we know that whenever we introduce resistance or inductance in a circuit, like voltage drop takes place. So ER plus EL will be equal to capital V. This is very clear to us. And also I can say that total current flowing in this circuit will be equal to IR, will be equal to IL, because in series the current flowing will be same. Because in a series connection, whatever current I am having here, the same current will flow in this resistance. So IR will be equal to I, and the same current will flow in the inductor. IL will be I. Okay, so this is very good. And when we will like change the different voltages, measure the current, we will get a straight line like this. So this is a linear circuit. Similarly, we have non-linear circuits. So electric circuits containing non-linear resistances, resistive elements for which the volt ampere characteristics is not a straight line. So very easy to now understand non-linear circuit. If the VI graph is not a straight line, if it is a curve, then it is a non-linear circuit. So let us suppose you make a fancy circuit introducing so many different elements. Now if you like measure like voltage, like you take any voltage, measure the current, increase the voltage, measure the current, you do it n number of times, and if you plot all the points, and if you get a curve like this, because this is not a straight line, but it's a curve. Then be very sure that, okay, the circuit which you designed, it is a non-linear circuit. So the characteristic of a non-linear circuit is that V and I, they are not directly proportional to each other. Like they can have some different relation. It will not be a straight line. To be very precise, V and I graph will not be like a straight line, which we used to be having in the linear circuit. For example, here we can see like V will be equal to, like here we have a diode and we have one load. So definitely the voltage will get distributed across VD and VL. But if I talk about current, current will be like, because it's a series, current will be same. So I will be equal to ID plus IL. So current will be same. So whatever current is flowing here, the same current will flow here. The same current will flow here. So I is equal to ID is equal to. But now when I will take different voltage and measure the current across the diode, I will not get a straight line. So like for now, remember, like later on we will prove it. We will get a feel like whenever we introduce a diode in a circuit, that circuit will become non-linear. Diode makes a circuit non-linear. Now, why is it so? What is so magical in the diode, or what special characteristic diode possesses because of which the circuit becomes non-linear? That is a matter of discussion, which we will discuss for sure. But for now, we have seen that, okay, whenever we introduce diode in a electrical circuit, that circuit becomes non-linear. Okay, students, now we will discuss unilateral and bilateral circuits. So what are unilateral circuits? An electric circuit whose characteristics change with the direction of its operation. So these are unilateral, like diode and transistors. For example, like what are unilateral circuits? If direction of current changes, then the nature of the circuit will change. Then that will be a unilateral circuit. Like if the direction of current is this, for example, the circuit will behave in some way. And if the direction of current is changed, if it is reversed, then this circuit will behave in a different way. Then we say it a unilateral circuit. For example, in this circuit, like we have a diode and we have a resistor. Now we have like two voltage sources, like they are connected in opposite direction. Very careful, be very careful. Like here plus minus, and here this is the plus, this is the minus. So here we have like forward voltage, we have reverse voltage. So see, what I have done is I have two voltage sources which are connected opposite. The terminals, they are opposite to each other, as can be seen here. Plus minus plus minus. Like plus minus is this and this is the minus plus. So now when I will close this switch, definitely like current will flow in this direction, positive to negative. So this circuit will behave in some way. Like this will be the VI graph. And definitely VI graph will be non-linear because diode is present. This we just now saw that whenever a diode is present, the circuit will become non-linear. So VI will be a curve, that's fine, but this will be what it is. But now when I will close this switch, it is I1, then the current will flow in this direction, opposite direction, because of which the behavior of the circuit will change. So VI graph will become something like this. So this is a unilateral circuit, means if the direction of current changes, circuit starts behaving in a different way. And it is very sure, like seen it, whenever there is a diode present in a circuit, that circuit will be unilateral, because diode, if you like pass current in this direction, diode will behave differently. And if you pass current in this direction, diode will behave differently. Now, why it will do so, that we will discuss. But now it is very clear to us that whenever we introduce a diode in a circuit, the circuit will become unilateral. It means that one direction of current, it behaves in a certain way. And if I change the direction of the current, it will behave in a different way. And diode, and similarly, if I introduce transistors in a circuit, because in electronics, transistors plays a very important role, then also your circuit will become unilateral. All this we will discuss in some other lecture, like why diode and transistors make the circuit unilateral. So for that, first we will feel what is diode, how diode works, how transistor works. Then you will get a clear picture of it. Now we have bilateral circuits, an electric circuit whose characteristics are same in either direction, like resistors, inductors, transmission lines. So the idea is that if a circuit behaves the same way, regardless of the current can flow in either of the direction, the behavior of the circuit is same, then it is a bilateral circuit. For example, here, if I close this switch, then the current will flow in this direction. Then the VI graph will be something like this. And if I close this switch, current will flow in this direction. So we know that if I talk about the resistor, in either way you pass the current, it will behave same. So resistor is basically a bilateral element, and inductor also the same way. Inductor, there is no terminal for inductor. You can connect it in any way you want. It means that it is not dependent on the direction of the current. So resistors, inductors, any way the current will flow, it will behave similar. Very important application we have of transmission lines. You might have seen transmission lines. In transmission lines, we can pass the current in both the direction. We can supply the current either this way or the opposite way. It supports both. So transmission lines is a bilateral circuits, because in both the direction, if the current is passing, it will not get affected. So these are bilateral circuits. Okay, students. Similarly, we have passive and active networks. So if I talk about different type of DC circuits, so we have active networks and passive networks. So what are active networks? A network that contains energy sources together with the circuit elements. So those are active networks. So very easy to understand. If in any electrical circuit you have an energy source, then for sure this is an active network, because this network is active. It means this network is getting continuous energy. This network is getting continuous energy. It's an active network. So we can have a EMF like a voltage source, or we can have a current source. So we will discuss in some detail about current sources, because voltage sources we are very familiar with, like batteries we use a lot in real life also. But current sources, like you might not be aware of it, we will discuss that. Then we have passive network, a network that does not contain energy sources together with the circuit elements. So if a network does not contain energy sources, then definitely it's a passive network. Here we can see in this circuit, there is no voltage source or current source. It means that this circuit is not supplied with energy, and hence it is a passive network.